Fine-tuning. Here you go. Same structured format for fine-tuning. Fine-tuning in artificial intelligence. Intermediate means advanced model customization. Introduction. Modern AI models, especially large language models, LLMs, are often trained on massive general datasets. However, real-world applications require models to specialize in specific tasks, adapt to domain-specific data, improve performance for particular use cases. This is where fine-tuning comes in. Fine-tuning allows us to take a pre-trained model and adapt it for a specific task or domain. What is fine-tuning? Fine-tuning is the process of taking a pre-trained model and training it further on a smaller, task-specific dataset. In simple terms, fine-tuning equals customizing a pre-trained AI model for a specific task. Example concept. Pre-trained model means fine-tuning means specialized model. Why fine-tuning is important? Fine-tuning is important because it improves task-specific performance, reduces training time, leverages existing knowledge, enables domain adaptation. Without fine-tuning, general model means less accurate for specific tasks. Key idea behind fine-tuning. Instead of training from scratch, we adjust an already trained model. Example. General language model means fine-tune on medical data means medical AI assistant. Checkmark the model becomes specialized. Types of fine-tuning. 1. Full fine-tuning. Update all model parameters. Advantages. Maximum performance. Disadvantages. High computational cost. 2. Feature-based fine-tuning. Use pre-trained features and train only final layers. Advantages. Faster training. Disadvantages. Limited flexibility. 3. Parameter-efficient fine-tuning. PEFT. Update only small parts of the model. Examples. LoRA. Low-rank adaptation. Adapters. Advantages. Efficient. Cost-effective. Fine-tuning architecture. Key layers. 1. Pre-trained model. General knowledge. 2. Task-specific data. Domain dataset. 3. Training layer. Adjust parameters. 4. Evaluation layer. Measure performance. 5. Deployment layer. Specialized model. How fine-tuning works. Workflow. Load pre-trained model. Down pointing arrow. Prepare task-specific data. Down pointing arrow. Train model on new data. Down pointing arrow. Adjust parameters. Down pointing arrow. Evaluate performance. Down pointing arrow. Deploy specialized model. Example. Conceptual. Def fine_tune_ model. Data. Return model adapted to specific task. Print. Fine_tune_ model. Domain data. Fine-tuning techniques. 1. Transfer learning. Reuse pre-trained knowledge. 2. Layer freezing. Freeze some layers. 3. Learning rate scheduling. Adjust learning rate. 4. Regularization. Prevent overfitting. 5. Data augmentation. Increase dataset diversity. Real-world applications of fine-tuning. Chatbots. Domain-specific assistants. Healthcare. Medical diagnosis models. Finance. Fraud detection. Legal systems. Document analysis. Code generation. Specialized coding tools. Advantages of fine-tuning. Advantages include improved accuracy, reduced training cost, faster development, domain specialization, efficient use of data. Example concept. Fine-tuning means specialized AI means better performance. Challenges of fine-tuning. Challenges include risk of overfitting, need for quality data, computational cost for large models, catastrophic forgetting, hyperparameter tuning complexity, fine-tuning versus pre-training, pre-training, general knowledge, fine-tuning, task-specific learning, comparison, Pre-training means broad. Fine-tuning means specialized. Fine-tuning versus prompt engineering. Fine-tuning modifies model. Prompt engineering modifies input. Comparison. Fine-tuning means deeper change. Prompt means quick control. Best practices. Use high-quality data. Improve results. Start with pre-trained models. Save time. Use small learning rates. Stable training. Monitor overfitting. Validate performance. Use PEFT techniques. Reduce cost. Future of fine-tuning. Future trends include parameter-efficient methods, automated fine-tuning, domain-specific foundation models, continual learning, integration with RLHF. Example concept. Future fine-tuning means efficient and scalable customization. Concepts learned from fine-tuning. Understanding fine-tuning helps learners understand. Checkmark how to customize AI models. Checkmark how transfer learning works. Checkmark how to improve model performance. Checkmark how to build domain-specific AI. Checkmark how modern AI systems are adapted. Simple definition. Fine-tuning. The process of adapting a pre-trained AI model to a specific task using additional training. Final summary. Fine-tuning is a powerful technique for customizing AI models. It enables specialization, improved accuracy, efficient training. It is essential for building real-world AI applications tailored to specific domains.